Us. Hey folks, good afternoon. My name's Pete Follett. For anyone who hasn't met me before, my pleasure to be co-hosting this event today on behalf of the Queensland Water Modelling Network. So I come from the International Water Centre, where together with Sarah Cochran and Brian McIntosh, we look after some of the engagement activities for the DES team, working with Jenny Ritchies and her team there. So pleasure to be talking with you all today. And from the outset, I acknowledge the traditional custodians of the country where I am today, here in the Turrbal and Jagera people, and acknowledge the various nations from wherever you are, and acknowledge any traditional owner and Torres Strait Islander people who might be on the call today, and welcome to you all. Folks, today what we're doing is starting just a very short series on some highlights from some recent commissioned projects through the Water Modelling Network, through the Research and Development and Innovation Initiative that's been going for a few years now. So these projects are quite detailed examinations on the utility of various modelling tools across a range of topics. And today we're starting off with one that's focusing on some work that's looking at initiatives here in Southeast Queensland. So it's my pleasure to welcome Tony Webber on behalf of the team, which is a mixture of BMT and Griffith University, together working with Healthy Land and Water, who were also co-investing in the production of this project. So thank you very much for that diversity. And look, some of you would have met Tony Webber before. Tony's been involved in catchment modelling for quite a while, and I think he might even allude to in the presentation that some of the things he's working on today have needed to evolve, and he was been involved in some of the early catchment modelling initiatives right at the outset back in the late 90s and early 2000s. So Tony, welcome. Thanks for being involved and having some time. And I know Michael Barry, who's also involved in the project, is also online. So if you've got any questions for Michael during the course, feel free to flick comments that way. We're keen to use the chat as a bit of a repository for any comments. But okay, Tony, I think we're going to jump into it. And look, today we're trying to focus on not only the utility and some of the design issues behind these models, but what does it really mean in some of the bigger picture in terms of the big ideas that are coming out of this sort of work? So look, where are we going, Tony? I'm going to bring you up with the two of us. The two of us are going to be talking. The system will figure it out and record. But Tony, the history of water modelling in Southeast Queensland isn't something that's happened in recent times. It's been happening for quite a while, and in a way, this project has come about by the need for a bit of evolution. But why has that been so, Tony? Please take the floor.
Yeah, it's actually very interesting. Just acknowledging the traditional owners of the land on which I'm in today, which is the Ngunnawal people, because I'm in Canberra, and that's actually quite serendipitous for this webinar, because the real push for doing solid catchment modelling in Queensland really came out of work that commenced here probably in Canberra and ANU, and then in the CRC for catchment hydrology at CSIRO and with CSIRO. Back in the late 90s, you may have heard of tools such as EMSS, and there was actually a local scale version of that in Moreton Bay Council, which is quite interesting as well. Pine Rivers, actually, a long time ago, and yeah, I won't say the other thing. So, you know, Southeast Queensland has been quite important in the development of modelling, and to be honest, the development of EMSS and then its successor software E2 really came out of all of the efforts that were going on initially in Southeast Queensland, and that's led to the development of, you know, platforms like Source, which are now used Australia-wide and a little bit internationally as well. So, you know, it's been quite good to have been involved with that development from the very beginning. But the other thing that it's taught me is that history also demonstrates the amount of limitations and assumptions we've had to deal with over the last 20 to 30 years. So, you know, that for me has always been a bit of a bugbear. I've always been quite passionate to try and do something different, to think about how we understand catchments and their connections to waterways and receiving environments in newer ways, or in ways that may allow us to understand them better. Yeah.
Right. Okay. Well, look, Tony, just give us a quick snapshot of what the sort of look of this sort of new approach has. Like, from listening to you, you know, you've got something with a couple of models, and one of the interesting things is the interface of what the alignment is trying to do. But anyway, let's just give a quick picture so people have a
Yeah,
feel.
I might just, if it's okay, just throw up a quick couple of slides if I can figure out how to share from here. Oh, there we go. The one right in the middle that says share screen. Yeah. If I just quickly do this to slideshow. Is that popping up okay, Pete?
That's full screen now. That's great.
Yeah. Yeah, and look, I feel like I'm a bit of the showman, frontman person. The smarts here is Michael Barry and the team at BMT at Tuflo. I think they put you know, a lot of the knowledge and thought into this. Also acknowledging Griffith University and both for you, who's was looking at alternative models as well at the same time. But really, the whole idea around this was to start to think about how we could break up the problems, or get around a lot of the problems that we'd identified over a number of years of trying to bolt together a fairly lumped representation of the landscape and seeing how that connected to the receiving environment. The Tuflo suite has obviously been around quite a long time, and it's seen development in the areas of flooding and in detailed receiving water modelling and sediment modelling and so on. And it provided a platform for us to think about how we could do this better. We actually built and applied a pilot model in the Oxley catchment as a way of trying to demonstrate how this might work, and we've been also did all the documentation as well. But really, I think exemplifying this in the way it was implemented in the pilot model, it's really around trying to understand the landscape, the surface water connections to the stream network, and what that means in a dynamic fashion. It's no longer trying to say we've got to look for areas of homogeneity, in other words, things that are the same. Like even in that picture you see there, there's areas of green, there's areas of browny grey. You know, like our catchment models would tend to look at it like that. Oh, that's an area of green stuff, so I'll simulate that in a particular way. That's an area of browny grey stuff, I'll simulate that differently. We're no longer thinking about that. We're actually thinking about it. What is each cell or each part of that landscape actually doing, and how do we actually represent the characteristics of that and its influence on what happens with the way surface and subsurface flows might occur. So it allows us to start to break our thinking away from having to lump things together with that commonality, to actually saying, let's get back to what I'd say is first principles. How do we come back and say, this is a tree in the landscape. If I put more trees here, what does that do? If I make this surface go from vegetation to concrete and I put a big culvert in the middle of that, what does that do? And really, that to me is about starting to join together the understanding of hydraulics and surface water flow with our understanding of what that flow liberates and does as it moves down through the landscape. So that to me is the fundamental change here. we are no longer looking at constraining ourselves by our ability to necessarily have land use mapping. Now we might be constraining ourselves to being able to go out in the field and measure the size of a pipe, or seeing how many trees are in the landscape or whatever. And so it can change the way we think. And for me, while it's nice to develop this product and all of that, what's really been quite exciting for me is the ability for us to think differently about the landscape. And that for me is exciting. And honestly, we haven't tried really how far that can go yet. We're very formative stages of this. But we're really looking at trying to understand, you know, the conceptualization here in a much more detailed way, looking at, you know, what happens when rain falls on the landscape, how much gets into the ground, what might come out as subsurface or return flows, what comes over the surface, what's the difference between dissolved pollutants and particulates, how is that affected by things like evapotranspiration and surface roughness and all of that sort of thing. And actually having that embedded within the model, rather than just trying to calibrate something and say, oh, well, I get a good representation here, so the numbers must be right about what I've assumed in the landscape. And so that to me is the fundamental change. No longer are we trying to calibrate by saying, oh, maybe I got my imperviousness percentage slightly wrong. That doesn't matter anymore. Your imperviousness percentage is in the landscape. It will generate what it generates. And now it's actually trying to say, okay, well, have I got the surface conditions right? So that's a pretty big change. So it's not a lumped hydrology model. It's rain on grid simulation, and it's about equations of motion now. So that's fundamentally different to how we understand, or how we've simulated in the water quality sense. And that's the real important part here. This isn't, we've got hydraulic models, we've had rain on grid models. We're actually now trying to make that work with water quality. And so we're bolting together our ability to look at fine scale detail around things like surface runoff, which you've got here, and the difference in characteristics between that, and also being able to go from things like water level to flow, which is really what this is showing, is that now by that representation of landscape and channel geometry, we actually could start to use water level measurements as part of the calibration process, whereas we've never been able to do that before. And that is also frees up our ability to access much more data in terms of how our catchments work. So that to me is also quite revolutionary in the way we might go about calibrating and validating our models. It also allows us to see natively changes in the way catchments respond. And if you look at the top graph, that's in the upper parts of the Oxley catchment, where we're mostly vegetated. Now, simply through representation of the landscape and the channel geometry and the hydraulics, we're able to show that as you move downstream into the urbanisation areas, we're getting that model representing the fundamental change in hydrology, the fundamental change in the way the hydrograph responds to rainfall. And we've only ever fudged that, for want of a better word. That may be a naughty word, but we've only ever been able to do that previously by the way we might think about how we parameterize different parts of a hydrology model, not actually natively representing them. We've also had to think completely new ways of looking at how constituents might be generated, because no longer are we saying if there's a flow, there's got to be stuff going with that flow. What we're saying now is if it rains, rain might happen on a bit of the landscape, and then that landscape might generate pollutants or it might not, depending on what the surface is or how much it's accumulated or whether it can wash that material off. And so we've started to think about how do we, and this to me is another part of this, is how do we set up a framework to model something that's got enough flexibility to try and cater for all of the things that we might want to do? Not lock us into a particular paradigm, but actually free us up to be able to look at different ways of thinking about how pollutants might be generated or how they might be liberated and so on. And so again, it comes back to how we start to simulate those things. What do we start to be able to go from because we've only ever been able to lump things up in things like total nitrogen and total phosphorus, whereas now we might be able to get down to particulate phosphorus and soluble phosphorus in a model that actually represents how they move through the landscape. And that, to me, again, opens things up quite significantly in terms of how we might simulate things. We've also then been able to couple directly to a receiving water model, and this is probably one of the biggest advantages of this package, is that if we want to represent the receiving environment, no longer are we running a catchment model, spinning out a whole heap of results, throwing that over to the receiving water modeler, who then's got to reinterpret them, analyze them, repetition them, change time steps. All of that now is seamless, and we remove a lot of the errors that were occurring in that interface before humans were involved. So the saying I have is, we remove the plebcat problem, which is the problem lies between computer and chair. That's gone. So again, we're focusing more on, okay, we see these connections now. Are these connections showing us the right response in the receiving environment, and what does that then mean? And so that also allows us to get far more sophisticated around some of the visualizations that we might be able to do here as well. So we can start to think about the way we represent the landscape in more detailed ways. So look, that's really quickly describing what's been 12 months of really hard work, especially by the Two-Flow team. And it's really just to give you that overview of what's going on with the package, or with the project that we worked on.
So Tony, as a bit of a pilot, is it more like you've looked at Oxley Creek there, so you've got a basis. So like I suppose for a group like Healthy Land and Water that have sort of been an active user of modeling tools for a whole range of things, what do you, and maybe later we can get the Healthy Land and Water people to come in and comment, but in terms of some of the key information for them, what is it that's different, do you think? Like I can hear that you're dealing with that variability in the catchment a lot better than what you've done in the past. So yep, that hopefully takes out some of that noise and generalization. But for the various sort of users, what do you think this is starting to allow them to do now that they haven't been able to do in the past?
One of our biggest challenges, I think, in understanding catchment response has been our ability to represent intervention, whether that's land use change, whether it's riparian restoration and so on. Largely our way of simulating that is to think about its conceptualization and then represent that as a percentage change or a series of algorithms. What I think this allows us to do is actually physically place these things in the landscape and say, what difference does that make? Now, that's not saying that it'll represent the way that system might work exactly. For example, if you go and revegetate part of a channel, not only have you introduced roughness, you've reduced the erodibility of that stream and so on, and some of that will still require you to parameterize the channel in a certain way. But at the same time, you've moved away from lumping everything together in a big blob and saying, I've restored this length of stream and that I expect it to do 20% reduction, to actually saying, here are the bits of stream I've been able to revegetate. What is it actually doing to the flows? What's it doing to the pollutants that might be coming through that? And that, to me, I think has got a hell of a lot of potential, which we've not even started to explore yet.
Okay, interesting. Yeah, look at this. There's a good bit of conversation happening in the chat around some of the technical issues. So thanks, Michael Barry, about talking about some of the challenges around the sort of the grid size, because I suppose this is the new dynamic, how you manage and cope with all that sort of additional information that's coming in. So yeah, but hey, look, Jack from Healthy Land and Water, is there an initial comment that you'd like to to share about what some of your initial impressions are from the user's point of view in terms of what the models are? Is there something you'd like to add, Jack, at this early stage?
Tony absolutely touched on it in terms of the capability for the scenario plan.
Okay.
Scenarios. Obviously, that's been a component of models in the past or previous modeling exercises that have used source catchment and receiving water quality models. But yeah, to get that level of information on various intervention scenarios or policies within smaller geographic areas, I think could be incredibly valuable for planners and policymakers. I think in terms of how we've been using the models to date for the condition assessments, I think since 2015 we've used the source catchment model and receiving water quality models to inform the condition assessment of waterways in southeast Queensland. And yeah, those issues that Tony raised are around the numbers and assumptions around how key water quality processes are represented in those models. To see that advance such a big way for this small area, I think illustrates the power of that. I think the key challenge will be, absolutely, with that huge amount of information, possibly a requirement for more monitoring to inform model development. Would be how do we foresee that moving forward at the scale of southeast Queensland to inform that regional picture of condition and also policy and planning perspective. So yeah, there's probably a lot more to discuss in detail.
Look, I think that's an interesting first step, because I suppose this is a pilot. It's meant to sort of see what's possible. And I suppose, Michael Barry, I was just going to, I know you're busy there in the chat writing good responses. Thanks, Michael. But Michael, if you wanted to come on and I suppose in like Tony's highlighted how you were doing a lot of the sort of mechanical technical work and behind, but as an approach, are there some sort of general comments you'd like to make in terms of how workable this was for this sort of an initial sort of pilot application? Putting Michael on the spot here, I realise.
For some reason your microphone's not working, Mike.
Oops.
Okay, how's that? Is that better?
That's better. Fantastic.
Thanks. Yep. So what I'll say is that I think to support what Tony was saying is that what we've tried to do in this project with the support of the modelling network and Health and Water is to move from a way of thinking which is top down, so make large scale assumptions and hope they work at the small scale, and then really asking environmental questions at the small scale, having made large scale assumptions, to a paradigm where we say, let's actually parameterize and understand the small scale, and let's work bottom up instead of top down. So we're offering users the ability to really drill into detail in the way that they simulate these processes, and not have to make assumptions end of pipe, but actually have the top of pipe calculations doing the work for us in that regard. And what that means is we can answer questions like Tony said about, if we do something right here in the catchment, then what impact does that have on water quality downstream? Not in this big lumped catchment, we've done something, how are we going to work out how to capture that change at the downstream end of the catchment? We're moving away from that top-down approach to a bottom-up. So that really assists us when it comes to calibration, for example, because it means that we can parameterize hydrologic and hydraulic processes as they are on the ground. So if there is a pipe network that's taking water from here to here, we can just put that in the model and have the model simulate that for us with the equations of motion, instead of trying to guess about how that might actually be captured in a lumped model. So from a practical implementation point of view, it was actually a much, much simpler process with a much richer calibration data set, as Tony mentioned, because we've got access to water level gauge information now that we can use because we're simulating water level, to have a much more robust calibration process that was quick on the catchment side. And on the receiving side, which is my majority of my background, I suppose, receiving water quality modelling, which I've been very happy to work with Healthy Land Water in its previous incarnation since way back 2011 or 12, Tony. I think we started doing that sort of work. The most difficult things for us practically in terms of a project were that linkage, that physical linkage between catchment and receiving model that Tony talked about. And also speciating total nutrients that come from a catchment model into a receiving model that needs speciated nutrients like total nitrogen to ammonium and nitrate and organic nitrogen. We're now simulating those species in the catchment. So we don't have to do that speciation anymore. So from my point of view, that's awesome. It just makes things so much easier. So the manual linkage is gone, the speciation has gone. And when we built this Oxley model and the guys did the catchment modeling and produced boundary conditions for us, I built and ran the Oxley two-flow FE model, and it took about 3 or 4 iterations to get it calibrated to a standard that I was okay with. In the past, it would have been 30 or 40. It just worked because the linkages were as the ground was telling us, you know, and we didn't have to make guesswork assumptions about speciation, and it just worked. It was incredible. So you're asked about practical implementation, Pete. That's the response there. In the overall context of moving from top down to bottom up.
Okay, so we're obviously looking at a little bit more of a sophisticated sort of modeling environment here, isn't it? So and it sounds like there's a lot more data involved. So setting up one catchment is obviously a bit of work, but
and I think that's the important point here, Pete. I mean, we're not saying that lump conceptual models are finished by any stretch of the imagination. There will be times where you can't spend the time or the resources that you need to get the amount of data that you might need to properly represent the landscape in sufficient detail. It doesn't mean you couldn't use two-flow catch in that case, but you may find that it might be a little bit more difficult to calibrate. The other thing is that going past the lump conceptual models, which obviously take a while to set up and calibrate, but have very fast run times, means you can do some things in terms of running multiple models and stochastic generation, etc. Those sorts of things, stochastic climates and that sort of thing. With this model, the computational time is obviously going to be longer. It's a far more complex model, but it's not. We're not talking weeks. We're talking hours here, because and look, this is exactly the same as what happened with the development with the catchment models. When we first got catchment models, I'd run the old EMSS model, and it'd take a complex model of SEQ would take an hour and a half to run. Now that runs in like a minute, that same model. Not because the model's got any simpler, but simply because our computational power has got that much greater. And, the ability to use the two-flow engine and GPU capability means that what we're going to be able to do is to really start to now use the complexity in a more efficient manner, I suppose. If I'm not probably saying that the right way, but you know what I mean. The computational power is now freeing us up to have much more complex models, and that for me is something that we shouldn't ignore. We should be trying to look at how we use, So
yeah, I agree with that, Tony. It's something that has certainly been a constraint in the past, allowing this sort of specification of detail, but we need to shift our minds a little bit to realize that compute power is just going ahead so fast these days. Like GPU cards, all our software is GPU accelerated. GPU cards that we bought 2 years ago as top of the range, they're not available anymore because they're so out of date. Like, it's just going so fast. So yes, run times will be longer and are longer when we do it this way, but the value and benefit you get from it is far outweighed by the runtime that we now look at. So, and those runtimes are only going to get shorter. So yeah.
So does that mean for the users and like for Jack and his team, does that mean they can give you a few more different scenarios to test than what they've been able to do in the past? Like, is that where some of the benefits are? Because that's often, I think, you know, in terms of management options and the what ifs, it's always that sort of combinations or.
Yeah. I think my main thought there is that in the past, to run scenarios, we would have had to have had a couple of grunt machines in the office, perhaps, and bank up half a dozen simulations on each of them, and then go away and come back in a couple of months and see how they're going. Not quite, but more or less. Now cloud compute allows us to run all these in parallel. So what would take 24 one-day simulations in the past, now we can get done in 1 day by running 24 simulations on the cloud at the same time. So that whole parameterization of scenarios is probably going to take more time to set up than it is to run, because we can just bang them all out on the cloud now. It's another game changer in the compute space.
So what's this mean for the interaction between the modelers and the users? Like, is there a new sense from users on how informed they need to be on what's possible, or is it this part of the, and maybe Jack, you from the Healthy Land and Water team, like how easy was it for you when you're working on this sort of, like, this project was a bit of a pilot, so that ability to sort of articulate the sort of questions you would like to answer, did it sort of match the availability of different data that was available, or how did that look?
Yeah, so I'd say I'm still digesting the details of a lot of the work. Yeah. But overall, I'd say what it's opened up in terms of that, I guess, that opportunity to explore and represent processes that haven't been reflected previously.
Okay.
Opens up a whole lot of opportunity in introducing our remotely sensed data sets and other I guess data sets on catchment condition that I don't think have been incorporated previously into these large scale catchment water quality box. So I think, yeah, it'll probably take some time for us to digest and understand the capability in the context of some of the questions we want to ask, but I think it also points us to how we might conceptualize and monitoring differently in some instances where we've got some more insights into catchment mass balances of sediments and other nutrients that are moving through the landscape. So I guess for the receiving water quality modelling, a lot of the work will be at concentration data. We've got event load monitoring stations looking at TSS load and nutrient load through time. But we know there's stores of those components through the whole catchment network. So thinking about the monitoring of the catchment condition with that in mind in terms of mass movement of some of these constituents, I think also opens up a lot of possibility.
Fantastic.
Thank you. Yeah, Iris wants to speak. Also, Jack, just in your microphone's not awesome. We're not quite catching all of the info from you.
Is Iris there? Hi, Iris.
Yeah, hi. I think when we set up this R&D project, I think the bigger idea is it just develop a model that have capability and functionality to do a lot more detailed, smaller scales changes in the catchment. For example, for us, it's really important to capture those restoration efforts or those erosion processes. So I think now what they deliver is it's really setting up, changing the scenes that the model is capable to do that. But of course, we know that this is just a pilot and we need more time and investment to further expand that to Southeast Queensland. But I think the point in here is with this new model platform, that we know that the model is capable, and also for us it's also important to share this information with end user, it means that previously, if you think we only need to collect data of TSST and TP, but now if you have the speciated data set, we will also use it in the model because the model is capable. But previously, it doesn't got the speciated functionality in here. And I think it just also, it's not only developing, so for this project, it's not only developing a new platform, but the new platform also giving us the idea that what type of data sets will be helpful to have a better estimation for the catchment. And all this algorithm in the model, it's just backing up by better science.
Okay.
I think it's a reciprocal type of positive loop of change.
So you're looking at maybe sort of some refinements or new areas of sort of on-ground monitoring that you might need to do to...
Yes. So for us, definitely is trying to get a more detailed resolution in terms of the erosion processing, because that's important in Southeast Queensland. And I hope that, how can we, what data you need to have a better representations and better estimation in that model. It's something that I think it can actually show us what we need.
Yeah. Okay. Look, I'm going to come back later on to Mark Silburn, who's just walked out of screen at the moment, to sort of get a sense of maybe what this approach means for some of the Great Barrier Reef catchments where this is happening. But before I go there, like, I know John's been quite busy online there, John Clarick, about some of the technical issues, but and there's some good responses. But John, is there some, like, there's a few of you online that are very involved as detailed modelers, but John, are there some sort of comments that you'd like to make? You've had a series of questions trying to understand some of the sort of the detailed aspects. What's sort of jumping out at you as some impressions of this approach from your experience in the past? Oops, your microphone might not be on, John. Oops.
Is that a bit better?
Yeah, that's it. Lovely.
There we go. Sorry, picked the microphone out of the room for some reason. Yeah, so yeah, I mean, this is awesome. This is a great progression, guys. So great work. I suppose the next question I was having, was just typing in the chat, was around, like, is there going to be a phase of the pilot, I suppose, where you kind of look at the model and go, all right, now that we've got the capability to have, varying inputs meter by meter for ground infiltration, for, subsurface infiltration and capacities, roughness on all sorts of different terrains and things. Is that going to drive kind of gauging decisions, I would like to hope, where to put, how are we going to model these things, how are we going to get data for these areas, so that way we can, even if we can't, even if we're not going to know exactly every single step, presumably you're not going to measure the roughness of every single square meter in Southeast Queensland, but even just some different pilot areas with varied topography, various coverage, to try and go, all right, what is the sort of typical distribution of these sort of things? That's always kind of the problem, I suppose, with some of the 2D models, is that I've often seen, so, first of all, my background is I used to be the engine developer at XP Solutions, which was now within Innovise. So, I worked a lot on the nitty-gritty inner workings of the maths of all these sort of things. But yeah, I remember seeing a lot of people essentially just, they would take singular values for a lot of these values and go, okay, well, that's a road, therefore it's going to be this parameter. It's going to be, well, that's a green area, it's going to be this, and essentially just mini lumped models. It'd be nice to have, now that we've got the model, that we know it can work, how would we feed that with data, with distributions of data, to be able to go, all right, what does this actually look like for Southeast Queensland? What are the typical sort of ranges we would expect? And then be able to do proper sensitivity analyses, because that's the other one that's the problem. When you have so many more degrees of freedom and variability, how do you capture that variability? How do you account for it, given that, you can't just have a single parameter that maybe you fudge and go, okay, well, maybe it's a distribution and the average is maybe 10, 20% out. I can just move a single value and that sort of captures a shift in distribution, rather than how does the distribution itself sort of change given antecedent conditions or urbanization over time or whatever. But yeah,
Well, that's a good question, John, because I suppose it's sort of, yeah, there isn't a black and white answer. Tony or Michael, any thoughts?
Yeah, look, I'm not yet sure, and look, the next stage of this is for us to be able to apply it in another location, and have the time to and resources to do that, so that we can explore. It's nearly like doing a bit of modelling research, in effect, to see what is possible. I agree with you that we're moving to an ability to look at individual landscape components, like individual cells, and start to understand what's the significance of changing those to any degree. Does it even really matter if you start to play around with some of the material properties of the mesh? For some parameters, maybe it doesn't, but for some, they might become highly sensitive. We haven't even started to explore that yet and to see what might be important, though obviously there's a lot to learn from the rain on grid flood modelling that's been done. They know some of this stuff and what's critical. And I've been a lumped conceptual model for the last 25 years, so I've got a lot to learn about hydraulic modelling. And that's, I think, the exciting stuff around this for me is I can now start to explore that stuff. So I don't know if that answers your question, John, but it's more just to say that I think, yeah, we don't know yet exactly what our limitations are.
No, that's fully. I think it's going to be at least from my experience, it's often it's a long journey from the conceptual of just, let's do a big lumped models where we have, averages of distributions to, all right, now let's actually have proper data-driven modeling, data-driven decision-making. There's a massive conceptual change, which is we're going to use real data now. And also there's also a conceptual change, a philosophical change, I suppose, from, councils, regulatory bodies, et cetera, to go, we actually need to go out and get data for what does this look like in our cities, in our councils, in particular areas that we care about. If we want to make better data-driven decisions, we need data to make those decisions. So
yeah, I think that's right, John. And just to support what Tony's been saying, I think I got asked a question when this project kicked off about pretty much that. And I think what we're trying to do, the way we're trying to couch things is by saying, and it's sort of what Iris said as well, we're sort of moving from a space where we might not bother looking at these sorts of things because our models can't handle the data we'd get anyway, to saying, actually, our models might be able to handle a whole lot more now. Perhaps that motivates some more data collection or better understanding. We're trying to move, I think, in that direction. And that's what's exciting to me, is that we can start looking at answering these questions now because we've got tools to play around with to help us do so. And that's what I think is cool.
Yeah, nice. Very nice.
Mark Silburn, you're back in the room now. Mark, listening, you've had a lot to do with the sort of the GBR sort of modelling and monitoring. And in listening to the talk today, are you sensing that this sort of a platform or approach has potential in that sort of greater, broader landscapes where you're working in? Mark on the spot here. You're still muted, Mark. Oh no, here he comes.
Can you hear me now?
Yep, that's right. Thanks. Yeah, Mark.
I guess my team are not into this sort of catchment modelling. We model at a paddock scale.
Okay.
And but it's good to see the developments going on and seeing it being applied in Southeast Queensland. That's good.
But at that paddock scale, is that a lump paddock, or are you looking at the variability within those paddocks as well? That how I would have thought maybe there would be some sort of synergies in that approach.
We model many different paddocks,
Yeah.
and pull them all together and put them into the e-water source model.
Okay.
So we add them all up. Yeah.
Okay, that's the approach there. Fine. Well, thanks there, Mark. I appreciate that. Like it is interesting where the different modeling tools are being used. Hanshi, you had some questions there as we were going along around some of the parameters and the technical aspects. So does this what's this approach telling you for the sort of modeling that you've been trying to do in the wet tropics?
Well, in the wet tropics, we have wet and dry seasons, and I think that sometimes soil parameters can change quite a bit. So I was just wondering if we can be more dynamic in our parameterization of models. But it seems like interesting work that's happening with this approach. So I'll be keen to keep following Tony and his team's progress in this area.
Excellent. Okay. Any other sort of, like, there's been lots of great questions in the chat, but look, is anyone else in the audience like to come forward and pose a question? Happy for you to just speak out loud and wave your hand, or
hey, maybe not a question as such, but maybe a comment, sort of related to what John was talking about, where it can maybe feel like a step away from lumped models to mini lumped models, where we're still parameterizing homogeneous landscapes or ground surface types as one thing. And I think to an extent, when we are modeling entire catchments, that to be effective with our time, we do have to do this a little bit still. And there are data sets that capture very large areas, but maybe not to really fine resolutions that are always necessary. But even still, like, for example, maybe before we were looking at a subcatchment where we can only apply one infiltration set of parameters, where now we might be able to take a soil map, for example, and apply that across our entire model, where now our subcatchments have 4, 5, 6 types of soil types that, as water progresses through the surface there, they are infiltrating in different ways. So there's still a lumped approach where sand as a soil type is applied with one set of parameters, but where those parameters are applied is a lot more customizable with this approach.
okay.
Yeah, I think that's a really good point, Josh, that it may not be that we can simplify that we can add complexity to the parameters of a particular material or characteristic, but we might be able to get much finer in our representation of its spatial location and therefore its impact, so to be honest, I think that's an area of where we've still got an opportunity to calibrate, because the more we start sticking stuff in physically, the less chance I've got of fudging it, so for me, that's, I reckon, and I think it comes back to some of the comments in the chat too around, our ability to have the data to parameterize this. Sometimes I don't think we will have enough data to parameterize, 15 different soil types. We may still only come back to 3 or 4, but actually what we might now be able to show is that, here there's some direct connection of those soils in terms of their hydraulic conductivity to the stream, and other places they're disconnected. And, that's not what we've been able to do before. So it's, you'd love to develop these things and say it's going to solve all the problems of the world, but it's not. It's a step, and it's, the thing that's excited me most about this project is freeing ourselves up from the constraints that we've had in the way we've modeled the landscape before. I think we've been able to free up our ability to represent the landscape complexity now. And it will still come back to limitations on data, without question. It'll still come back to limitations on budget and resource and time. But at the same time, it also provides the opportunity to go further as well. And look, how do we do this at the whole of SEQ scale? I don't think we'll build one SEQ two-flow catch model yet. Maybe we will, but I think what we probably will build is what we've got now in our lumped models is 3 or 4 finer scale models that we have to represent particular receiving environments. You know, a Southern Moreton Bay, a Brisbane River and Central Bay, a Northern Bay, you know, or northern catchments. That, you know, that's probably how you'd think about the way you'd set up an SEQ style of modelling approach, rather than trying to say, let's do everything all together all at once. Because to be honest, I don't think we do that well anyway, even when we try to model it all.
Yeah, Tony, sorry, Pete, can I just add to that what Tony said? I think as an environmental modeler and software developer now, I think it's really, really important that we always make sure that we're clear on the questions we are asking. They will determine the complexity we need in the models that we set up. So we're not saying we need this level of complexity in every single modeling study from here till whenever. What we're saying is that if we are asking those more detailed questions, and questions will only get harder to answer and more detailed as time goes by, then the tools are progressing in a way to allow us to do that. We're not saying for a really simple study that might be, you know, scoping high level feasibility study, we don't need to have it gold plated. What we're saying is that when those gold plated questions come along, we've now got tools that can help us answer those a bit better than we had in the past. But it's always horses for courses.
Yeah. And look, and I suppose we know in Southeast Queensland over the last sort of 25, 30 years that, you know, the early focus many years ago was on some of the point source discharge, whereas now it's all really about trying to understand the diffuse source loads that are right across the catchments, whether it's the sort of the rural or the urban. But Jack, what does, I suppose one of the questions I was just curious from, based on what Michael said, is about that clarity of the next set of questions. Like Iris touched on maybe the need for some more monitoring, but from your team, from the Healthy Land and Waters sort of end, is that process of maybe getting some better clarity on some of the questions, like you talked about scenarios before. Maybe there are some particular scenarios you're trying to understand a little bit better, but is this sort of two-way process of working with the modelers and seeing what it can do? And like Tony said, it can't always answer everything, but are you getting a sense of maybe what some of the more sort of, you know, is this helping refine your questions that you'd like to have answered?
Yeah, I'd say there's a few focal areas we have currently. Yep. So at a high level, we're really interested in total nitrogen processes and budgets for catchments in Southeast Queensland and receiving waters in Moreton Bay. That might not necessarily mean we would apply this model to answer those questions as discussed, but yeah, given the sort of rate of rapid development in Southeast Queensland over the last decade, I would say we don't have a lot of good information on the impacts of some of these large regional development areas on receiving water quality. So I think investigation in that space with a combination of modelling and monitoring would be very powerful for management. So yeah, just a couple there. Iris might have a few more to add.
Yes, and so we also involved in an ARC that looking into offset space, and some of the initial finding is telling us that is not only don't look at the total nitrogen, but the speciated data, like the dissolved inorganic nitrogen, that sort of stuff. So I think in that context, if we have a catchment model that able to do the speciated nutrients, that will be really helpful if the policy is going to moving towards speciated data, speciated nutrients. Then with a model that's capable to do the speciated nutrients will be really useful.
And the whole, like one of the questions that have been sort of floating around recently has been, you know, prioritization and where to be looking at some of the interventions? Like in this sort of pilot, is there a sense that working through the behaviours across a catchment, that better understanding of where priority interventions could best occur, is that starting from the modelling team point of view? Do you think that was happening? And maybe from the user's point of view, is that sort of clearer as a way forward?
I think that's a really interesting question, Pete, around what does this model allow you to understand where to put stuff? No, I don't think it does. I think what it tells you is if you put stuff here, here's what will happen.
Okay.
And that's, you know, a different way of looking at it. And look, to be honest, I'm dealing with this on a couple of different fronts at the moment, is that if we think about where we want to invest in our catchments, to be honest, it's not a modelling question to start with. It's actually a capability question. Where can we do stuff? Who's willing to do it? How do we do it in a way that can be implemented? And then test that in a model to say, okay, if we do this stuff here, what's the output? You know, what's the result? We tend to think about solving our problems, you know, from that sort of top-down approach to say, I've got lots of money to spend, I'm going to revegetate all of this stream and it's going to work because I've got a bit of science that says, here's the link between, you know, revegetation and sediment. That's fine, but we've got to start at a process that say, okay, well, if you're going to re-veg, where can you re-veg? Where can you re-veg that's likely to have a large-scale impact? That's maybe not going to come necessarily out of a model, but it might come out of mapping, for example, or it might come out of a land use capability assessment, or receptiveness of landholders to have people come onto their property and do some work, you know. And so you nearly got to come at it from both ends rather than just saying, okay, can the model tell me where to do stuff, I think.
Look, I suppose that's the way, and I think with Healthy Land and Water working with all their various partners, understanding the capability of the different local government partners, the different sort of on-land groups that are, you know, are sort of looking after issues. Like I know, I think we're aware of some work that urban utilities are doing at trying to prioritise maybe some of the stream bank restoration across the region where it might be the best investment. So interesting. Okay, Mike Barry, is there anything, Mike? Thanks very much. Between Tony and yourself, you've been fielding quite a few questions there in the chat. Was there anything coming up in the chat, Michael, that you wanted to just sort of close off on? Like, thanks very much to, I can see one of our friends, Ruby's been busy there in the chat, checking on things.
No, it's great to have all these questions come through, Pete. It's and like I said before, it's really good to be in a position where we can start looking at these questions afresh now, and that's really what we're saying, I think, and horses for courses. So yeah.
Elisa, I can see your hand up. Is there something you wanted to query on? Thanks.
Thanks, Pete. I was just wondering, are you looking for more pilots?
Yes, please.
You beat me to it, Tony.
Hey.
Just particularly interested because of our history, I guess, with using source catchment modelling and for our infrastructure investigations and stuff, whether it's worthwhile a pathway to look at and look at the comparisons between those as well.
Yeah, I'm keen, and I don't know how necessarily we do this yet, but I'm keen to work with Mike and the Two Flow team and others to see even running this in parallel, you know, in some ways would be really useful to say, okay, what's the pros and cons? We did that to some extent in our project. Bofu developed a SWOT model and looked at what the implications of that was. We also had our source results for the Oxley catchment as well, so we knew something around, you know, and you know, the embarrassing thing was when Mike put up his calibrations versus the ones I got out of source or Aidan got out of source, and yeah, we won't talk about that anymore. But you know, it showed where the lumped models started to reach their limitations, I suppose, you know, and
The limitations. Yeah.
Yeah. So, and yes,
we'd be very happy to work collaboratively on that. I mean, that's where at the moment, pilot stage, collaboration stage. That's where so we'd be very happy to do that with you.
I suppose particularly because we've got all those future cases and things as well that it just takes it to that next.
Yeah, that's Lisa. No, look, that's the benefits of us coming together today is just to find out who's got an interest and appetite. And I'm sure for Jack and the team at Healthy Land and Water, knowing that there are other people out there that's sort of, you know, and how progressive, there's a bit more mechanics there to sort out. But Jack, it sounds like, you know, there's the appetite is there to explore this a bit more, and it's sort of this balance between how much more you need to make. And I think from hearing from Tony and Michael, it's not necessarily about the refinements, though. I think there's a proof of concept that the platform can offer something that's different from the past, and I suppose it's capitalizing on the fact they've got something that's different now. So, any sense, Jack, of where to next with the sort of collaboration that's happening here?
Yeah, I think Iris might have a few more comments on that as well. But yeah, I guess we're at an interesting stage in the program where we're looking at the capability of the current modelling suite and our key management questions that are relevant to Southeast Queensland, and we'll look for opportunities to, you know, build on this model and platform where we can and see how it complements some of those existing tools we have. Yeah.
Fantastic. Folks, I'm just conscious of time. We've reached 1:30. I know Tony's got to duck off. But look, particularly to Tony and Michael, thanks very much. To Jack and Iris, thank you too for being responsive. I know this has sort of been a bit of a Pete just asking questions, throwing in the mix, but also to quite a few people in the chat there, Ruby and John and Lucy and Hunchy, and a couple other people who have been active. Like we'll send, when we're finished, we'll send you all a recording to the link, which will then give you all the chat comments as well. But look, Tony, I know you've got to duck off. I'm happy to stay online for a little bit longer if anyone wants to talk a bit further. But look, thanks everyone. Like this has sort of been, I'm learning as I go along on some of these things too. It's pretty dynamic what's happening in this area, but it's been an encouraging one. And well done to the DES team for offering this, but also Healthy Land and Water coming together. So I see Iris clapping, that's just great. And to everyone for joining us, thanks very much, and enjoy the rest of your Thursday. And next Thursday, we've got Sharia Sullivan, who did some work on ungauged catchments and some matchmaking work. She's coming on to talk about that. And then in 2 weeks' time, Hunshi Lim's going to be talking about her paleo channel work that she's been working with in the Tully region, which is something quite interesting and different. So hopefully we see you again sometime, folks. But thanks for joining us.
Thanks, Pete.
Thanks all. Pete. See you later. Thank you.
Bye.